Hello, I'm Dustin Moss, a researcher in the Flux group at the University of Utah working on powder, and this is a brief demonstration of how you can use one of our controlled RF benches to test Open-Air Interface's 5G RAN elements. These test benches include two ADIS X310 software-defined radios with UBX160 daughter cards, connected to each other via coaxial cables and 30 dB attenuators. This provides an interference-free RF environment for repeatable testing and experimentation. An octa-clock provides a common 10 MHz reference and pulse per second input to each software-defined radio. The profile I'll be using for this demonstration initiates an experiment that includes SDR resources from one of the benches, as well as two near-edge server-class compute nodes running the OAI G-Node B and UE software. This demonstration exercises the RAN elements alone, operating without a 5G core network, but we'll be adding the OAI 5G core to the profile in the near future. With that, let's take a look at the profile in the Powder portal. Currently, this profile can also be used to stand up an end-to-end SRS RAN deployment, but we'll focus on the first option for now. There's a brief description and some simple instructions to follow after instantiating the experiment, which I'll do now. Here we have a couple of parameters we can set. There are two compute node options, and either will do in this case. We can also select which controlled RF bench we'd like to use, but we'll stick with the defaults. Now we'll give our experiment a name and start it up. It'll take some time for the experiment to become ready, but I have a similar one running using another one of the benches, so let's take a look at that one. You can see the topology of the experiment here. We have our two compute nodes paired with the X310 SDRs. Looking at the list view, we can see the SSH commands that will allow us to log into each node. I'll switch over to a terminal emulator and log in now. We'll use the commands provided by the profile to start the G-Node B, and then once it becomes ready, the UE. And we should see the UE quickly decode SIB1, initiate the random access procedure, and eventually reach the RRC connected state. At this point, we can see the G-Node B is reporting some HARC-round statistics for the uplink and downlink shared channels, indicating a stable connection with the UE. That's all for this controlled RF bench demonstration. Thank you for watching.